Hello once again, and welcome back to our ongoing look at the unit circle. So we are now pretty well familiar with the unit circle, what it means to be on the unit circle, and also what it means to move around on the unit circle. So we're going to go from there and start looking at the big six, the trigonometric functions. So let's get right to it. Remember from last time that let's say we had some number, call it t, and we start from 1, 0 on the unit circle, and we move t. Then our terminal point where we end up is determined by that amount. If t is positive, we rotate counterclockwise. If t is negative, we go clockwise. And wherever we end up after having moved t, that is our terminal point. And also, we looked at last time a few of the nice points along the unit circle, right? T is pi over 4, or negative pi over 6, or something like that. We would end up at a nice point, one that we should always have on our minds. Which begs the question, of course, well, if that's a nice point, what if I go something not nice? What if I move 1 on the unit circle? I mean, if it were on the real line, if I moved 1, I know exactly where I end up. I would be 1 over from wherever I started. But I'm not so lucky on the unit circle. Because if I start here at 1, 0, and I go 1, that means I'm going counterclockwise by 1. Well, 1 isn't a nice value, right? Going from 0 to pi is a nice value. Going from 0 to pi over 2 is a nice value. But going 1, not so much. That said, as I have up here, right, pi is about 3.14. Obviously, it keeps going past that, but it's about 3.14. So if I were to cut this semicircle into thirds, I would guess my terminal point should be about there, which corresponds to about, let's see, my guess is a little less than 1/2 and a little more than 0.7, looks like. The actual value is 0.54, 0.84. And there was no way I was going to guess that with what I have here, with just the unit circle. If you have a nice ruler and a lot of patience, you could trace out 1 along the unit circle, but really there's got to be a better way. And the better way I'm going to have us use is 2 functions that we can use to track the x and y coordinates as we move around the unit circle, both being functions of distance traveled, both being functions of t. So let's look at that. I've got a point p of x comma y. So the point's name is p, and the coordinates are x comma y. And that's our terminal point after moving t, some arbitrary unit, or some arbitrary distance along the unit circle. Well, I've got 2 functions for us here. I'm going to say x, the x coordinate of my terminal point, is going to be called cosine of t. So for any distance, cosine of that distance will give us x, the x coordinate. Also, the sine of that distance, sine t, gives us the y coordinate. So we have sine and cosine. Sine gives us y, cosine gives us x. And I have this bracket here because I want us to ask this question. Is this a parametric equation? And the answer, well, forget about the answer. We'll come around to this eventually. This is a question that you can bury and probably even forget about with no real issue for a very long time. But x coordinates we're now going to call cosine of t, and y coordinates we're going to call sine of t. So let's do a quick couple here. I've got sine of 3 pi over 2 and cosine of negative pi over 6. When you see these, what you interpret that to be, right now anyway, is I'm traveling 3 pi over 2 on the unit circle. What's my y coordinate? Because I'm asking for sine. Also, I'm going negative pi over 6, which means I'm going pi over 6 clockwise on the unit circle. And what is the resulting x coordinate? So what we do is pretty much exactly what we did before, finding that terminal point, finding those coordinates, only now sine and cosine is asking for specific coordinates, not the whole point necessarily, just specific x or y coordinates. So, sine of 3 pi over 2. I need to plot the terminal point, determined by moving 3 pi over 2, and then get the reference number, get the coordinates, and then find the y coordinate, and that's my sine value. So let's do exactly that. I start, I go 3 pi over 2, I end up at the point 0, comma, negative 1. I don't really need to do a reference point for that one. It's pretty straightforward. That one's good. And so the sine, the y-coordinate, is negative 1. By extension, right, by the other one, I'm going, let's see, negative pi over 6. So instead of going counterclockwise pi over 6, I'm going counterclockwise. The distance from this point back to the x-axis is, of course, pi over 6. I'm going to use as my reference point the one determined by moving pi over 6. That point is root 3 over 2, comma, a half. Therefore, being in the fourth quadrant, my x-coordinate is still positive root 3 over 2. So we get cosine being negative pi over 6, or of negative pi over 6 being root 3 over 2. And that's all it is. So this is just a very slight build-up from what we have been doing. See, whereas before we just got the point, now we're getting the point and pulling out the coordinates x for cosine, y for sine. We'll do a little more in the next, but let's just stop here for a bit. So I have a quick question for you. What is sine of 5 pi over 6? Just run that out for me. What is sine of 5 pi over 6? I'll leave this unit circle up here. You should have pretty much everything you need, so tackle that for me, and we'll pick up here in a second. So hopefully you agree that if we go 5 pi over 6, well, going from here to pi, that is 6 pi over 6. So my terminal point is just a little short of that. 5 pi over 6 is about here-ish. And so my reference number, t bar, is going to be pi over 6, because that's how much further I would have to go to get to the x-axis. So I'm going to refer to, actually, the same point I referred to here, root 3 over 2, comma, 1 half. So now that I'm in the second quadrant, though, x is negative, y is positive, so sine, the y-coordinate, is positive 1 half. And there we have it. Not a bad start. Now in the next video, we'll add on the other 4 big trigonometric functions, tangents, cotangent, secants, cosecants. They're not that much more, but they are still more. So look forward to it. See you then.